Hi, and welcome to the first lecture of Intro to Computer Programming, Section 008. I'm Andrew Eck, I'm your instructor. We're going to talk about a couple of things today. Ideally, by this point, you've read Chapter 1 of your textbook, which will be pages 1 through 36. So, agenda for the day. We're going to talk just a little bit of inspiration. We're going to take a look at a quote from Frederick Brooks of the Mythical Man Month. We'll talk about computers, we'll talk about programming, we'll talk a bit about Java, and we'll have a what can I expect. This is all going to be fairly introductory. I'll show you a little bit of what you can expect in terms of your workload, but by and large, or in terms of your workflow, but by and large, this is mostly kind of a broad level introduction. Let's take a look at some inspiration. This is Frederick Brooks. The programmer, like the poet, works only slightly removed from pure thought stuff. He builds his castles in the air, from air, creating by exertion of the imagination. Few media of creation are so flexible, so easy to polish and rework, so readily capable of realizing grand conceptual structures as programming. Yet the program construct, unlike the poet's words, is real in the sense that it moves and works, producing visible outputs separately from the construct itself. It prints results, draws pictures, produces sounds, moves arms, and so on. The magic of myth and legend has come true in our time. One types the correct incantation on a keyboard, and a display screen comes to life showing things that never were nor could be. Programming then is fun, because it gratifies creative longings built deep within us and delights sensibilities we have in common with all men. And that's Frederick Brooks of the Mythical Man Month. I apologize for all of the gendered pronouns. That'll be a thing that I guess we have to deal with. And so when you talk about programming, what we are often talking about is this sort of idea that you can type instructions to a computer and then the computer does stuff. But when we're talking about computers, it might be first useful to define what they look like. Joseph Campbell, who's a scholar who studies mythology and the role of myths and stories in the world, said that computers are like Old Testament gods, lots of rules and no mercy. Isaac Asimov, the science fiction writer, part of the inhumanity of the computer is that once it is competently programmed and working smoothly, it is completely honest. And in both these cases, what we're going to see, and what you're going to see repeatedly through the semester, is that the computers and the software that you write is going to do exactly what you tell it to do. The place where we're going to run into conflicts is when the difference between what you think you're saying and what the software thinks you're saying becomes apparent. And that's all right. So with computers, we've got four big components. We'll talk about the first three, hardware, the BIOS, and operating system, in sort of brief detail. And then ultimately, by the end of this course, or actually even by the very start of this course, we'll be writing software. Okay, so computers, historically, up until the 1930s, 1940s even, referred to people who were often women who were hired to do number crunching and informational operations by hand. So these would be, for example, in the First and Second World War, these would be folks who were hired to populate tables that would be used during the war. Now when we talk about computers, though, instead of talking about people, we're talking about things like microchips and hard drives and whatnot. And so the physical components of a computer, that's the hardware. It's processors, memories, hard drive disks, motherboards, monitors, input devices, and so on. The hardware is the stuff that you can see. That's the tangible stuff. The BIOS is the thing that runs the hardware. This is what you see when you first boot your computer up. If you've got a PC, if you've got a Mac, it doesn't usually show up. All the BIOS does is tell the hardware where to go and how to pass information between the different parts. The BIOS is the thing that talks to your operating system, which would be your Windows, your Ubuntu, your Mac OS X, your iOS. That provides a platform on which your software can run. Your operating system runs the whole thing by way of communicating to the BIOS, which then communicates to the hardware. Finally, we've got the actual programs. This is the software. You might use Microsoft Word, and in this course, we'll use PuTTY, which is a teletype software, and soon we'll be writing software on our own. Software runs on a computer itself. Sometimes it'll run on a computer elsewhere, which we call the cloud, accessible via web browser, or some combination thereof. And we find computers almost everywhere, which is to say you'll find them in your desktops, your laptops, your smartphones, your cars, refrigerators, thermostats, security systems, bicycles, calculators, windmills, and wristwatches. This is all moving towards the larger trend of the Internet of Things, wherein we have a whole bunch of related and connected devices that can all talk to each other. And so we're going to take a quick break here and then start over with what is programming.